Every plane you have ever flown on is carrying enough fuel to fill a swimming pool, and none of it is gasoline. Why? Gasoline is cheaper. Gasoline is powerful. Gasoline runs everything from your car to your lawnmower. So why does every single commercial aircraft on the planet refuse to use it?
The answer starts inside an oil refinery, and it ends with a fact that will change how you think about every flight you ever take.
Here is what most people never think about. Crude oil is not one thing. It is hundreds of things layered on top of each other. When refineries heat it up, different substances separate at different temperatures.
Gasoline rises near the top. Diesel sinks near the bottom. And right in the middle, at temperatures between 150 and 260 degrees, something else condenses: kerosene.
The same substance that lit oil lamps in the 1800s, the same substance powering every commercial jet aircraft on Earth today.
But here is the problem nobody talks about.
At 10 kilometers above the Earth, air pressure drops to almost nothing. And gasoline at that altitude does something terrifying. It evaporates. Not slowly, fast. The liquid turns to gas inside the fuel lines. Bubbles form, the flow stops, and the engine starves. Picture a straw pulling water. Now fill that straw with air bubbles. The water stops moving. The same thing happens to an aircraft engine running on gasoline at altitude. The fuel stops flowing. The engine shuts down. In mid-air. That is not a malfunction. That is physics. And kerosene does not do this. Its boiling point is high enough that it stays liquid at altitude. The flow never stops.
But that is not even the most important reason.
A large commercial aircraft carries up to 180,000 liters of fuel. On a flight from New York to Tokyo, nearly 100 tons of fuel burns through the engines. That fuel can account for nearly 1/3 of the aircraft's total weight at takeoff.
Now ask yourself, what happens if that fuel is as easy to ignite as gasoline?
Gasoline has a flash point of -43 degrees. That means in cold weather, even a tiny spark can ignite it. Kerosene has a flash point between 38 and 72 degrees. You would have to heat it significantly before it even begins to vaporize enough to catch fire. 1/3 of the aircraft's weight, sitting in tanks, in the wings, under the passengers. If that fuel were gasoline, the risk of fire or explosion would not just be high, it would be unacceptable.
And then there is the cold.
At cruising altitude, the outside temperature reaches -60 degrees. That is colder than any industrial freezer on Earth. If the fuel freezes, it turns to wax inside the pipes. The engine receives nothing.
So jet fuel is specifically engineered to remain liquid down to -47 degrees. Standard kerosene cannot do this. Jet fuel is kerosene that has been refined, treated, purified, and rebuilt from the ground up for the sky.
But here is the part that almost nobody knows. Before jet fuel even reaches the combustion chamber, it does something else entirely. It cools the engine. Inside a jet engine, the combustion chamber and the turbine reach temperatures above 1,000 degrees. Without cooling, the metal would overheat and fail. So before the fuel is injected, it flows through pipes running alongside the hottest parts of the engine. It absorbs the heat, it protects the metal, and then it burns.
The fuel does two jobs, cooling and burning, in that order, every single flight.
So the next time you board a plane and someone tells you it runs on kerosene, the same stuff that lit Victorian street lamps, remember this. That fuel was not chosen because it was cheap or convenient. It was chosen because nothing else could survive what an aircraft goes through every time it climbs to 10 kilometers and crosses an ocean. Gasoline would evaporate. Gasoline would freeze. Gasoline would turn a 100-ton aircraft into the most dangerous thing in the sky. Kerosene was not the obvious choice. It was the only choice. If this changed how you think about the plane you fly on, subscribe for more stories about the hidden engineering behind the things most people never question. I will see you in the next one.